Hello? Yes. We will have some issues with the microphone and this I'm sorry, I don't want to get injured by the microphone, but anyway, thank you all for being here. First, I want to thank our conference center team dealing right now with the sound issues, but be patient. And Yvonne Irving, Heather Gray, Lisa Langham, and Joseph are here to help us this afternoon, and as I play with the sound a little bit, I will make sure that it works. Yes? Okay. Yes? Can you? Well, anyway, welcome, and it's a pleasure for me to have with us today one of the most creative and really innovative colleagues working in environmental issues, Dr. Gregg Garfin. It's always a pleasure to work with him and to have him educate us and also share his wisdom on what's going on in terms of environment. And he's an assistant extension specialist in climate, natural resources, and policy in the School of Natural Resources and the Environment. He's the Deputy Director for Science Translation and Outreach in the U.S. Institute of the Environment, and he will be participating in the Festival of Books in 2 panels. 4 p.m. Saturday, he will be appearing on the panel, How Climate Change Will Impact Our Lives in the Integrated Learning Center. Different disciplines. Okay, yes, working. Okay, and I think without further ado, I welcome you, and you can begin the presentation, and then everybody has a chance to ask questions at the end. And thank you, Greg, for participating with the conference center.
Thank you, Javier. Javier likes to invite me to these sorts of things because I'm like the sensitive climatologist or something like that. And I read little poems that other people have written. So let me just start with a little bit of an invocation. This is just a little piece from a poem by Marge Pearson. So the discipline of blessings is to taste each moment, the bitter, the sour, the sweet, and the salty, and be glad for what does not hurt. The art is in compressing attention to each little and big blossom of the tree of life, to let the tongue sing each fruit, its savor, its aroma, and its use. Attention is love, what we must give children, mothers, fathers, pets, our friends, the news, the woes of others. When we want to change, we curse, and then we pick up a tool. Bless whatever with eyes and hands and bless whatever you can with eyes and hands and tongue. If you can't bless it, get ready to make it new. So, I'd like to thank Javier and the staff of the Conference Center for inviting me to speak, and also to thank Playground for hosting these events. It's a real nice to have an informal venue and a little lubricant, as it were. So I've been listening to a lot of podcasts of This American Life from National Public Radio. So I'm going to do this as a kind of quasi This American Life in 5 acts. So Act 1, how did I get here? So it's all due to El Nino. Well, not the late Chris Farley, but the climate phenomenon, El Nino, which every student, undergraduate, graduate who goes through any kind of climate program learns a lot about and generally falls in love with, because, you know, it's the mother of all storms. It's big and powerful. Anyway, when I started, not that long ago in the mid-1980s, thinking about El Nino, we communicated about it with diagrams like this one. And we've graduated to diagrams like this one. So just for those of you who are not familiar with the phenomenon, it has an ocean part to it and an atmosphere part to it. And it affects our region. So the atmosphere part has to do with, looks like the laser doesn't work on our screen. Anyway, start over on the right. We've got trade winds that blow from the east to the west across the tropics, and they put a lot of warm water across in the western Pacific. Warm water has this wonderful characteristic of imparting heat and energy. It evaporates a lot. It puts a lot of energy into the atmosphere up in the western Pacific Ocean, and it's a big contributor to the monsoons over there in the West Pacific. But, you know, what comes up, what goes up must come down. So there's, if you look at the brown arrows along the bottom, there's a return flow that goes across the Pacific Ocean, and as it descends and compresses in the eastern part of the Pacific, it's a drying flow in the eastern part of the Pacific, which is part of what explains why we have deserts along the west coast of South America. At any rate, every few years, this circulation reverses so that we end up with going from this sort of situation where we're piling up warm water in the western Pacific, which is La Nina, and again, it affects our region through something that climatologists call teleconnections, which it has nothing to do with the telephone, but it just really means that that's something happening in a very distant place. So something that happens in a very distant place can have a lot of effect in some proximate location like here. So this is, I would keep the volume low, and excuse me. If we keep the volume low, I'll keep this close to my mouth, okay? Very good. Thank you. So, so here's a diagram about how La Nina affects our region. So we're putting all that warm water over in the western Pacific, and over in the eastern Pacific, there's a lot of cool water associated with that descending circulation in the atmosphere. So as the jet stream exits Asia, that wonderful orange line over there on the map, it's taken all of that energy and moisture and it's imparting it way far north in North America in the wintertime, and it leaves us high and dry. So a lot of our infamous droughts here in the Southwest are associated with this kind of circulation. And it results in this kind of situation here in Arizona. But every several years, that circulation reverses, and we get El Nino, and we get warm water in the middle of the ocean. This is an interesting diagram, actually. This is showing the height of the ocean. So when things are warmer, they expand, right? So this is literally showing that the height of the ocean is much higher during one of these El Nino episodes in the central and eastern Pacific. So when we get El Nino, it's imparting all of that moisture and energy much further to the east, and that allows the jet stream that reaches us in the wintertime to have a lot more moisture. And we have a tendency to have wet winters. And for example, bad things can happen too. In the winter of 1983, thank you, we had an enormous El Nino out there in the Pacific, and some very dire consequences here along the Rito and the Santa Cruz. Big flooding that wiped out bridges on across the Rito and also here on I-19. And it's one of the reasons that we've invested a lot in more sturdy infrastructure, and why we've concretized the sides of the Rito wash there. At any rate, so I have a very intimate history with El Nino aside from studying it. So the arrow points to the 1957-58 El Nino, which is the one that sort of cut the legs out from under the 1950s drought, which was very profound in this region. Meanwhile, at the same time, over in New York, I was busy being born. In the mid-1960s, there was another El Nino, and my niece was born, and I became an uncle at the age of 8, which was quite a distinction among my peer group. In 1969, we had another major El Nino, and growing up in New York, that was the year that the New York Mets, the hapless New York Mets, won the pennant. 1982-83, I showed you some of the consequences here in Tucson. Meanwhile, over in Boston, I was playing with the rock and roll band Relentless Cookout. So that was a big highlight in my life, but pretty much commensurate with the size of that El Nino. In the mid-1980s, I was introduced to climatology at the University of Massachusetts, and that's where I first started finding out about El Nino, despite all of this intimate connection already. In the early 1990s, I moved here to Tucson, and I thought, gosh, it's wet here all the time, because we were having El Ninos. We had very wet winters and some flooding and stuff like that. And I got my master's degree, finally finished my master's degree from the University of Massachusetts. I moved here during this extended El Nino episode, and I started doing work on my PhD at the Laboratory of Tree Ring Research. During this 1997-98 El Nino, which some folks refer to as the El Nino of the century, I both finished my PhD and I also fell in love and got married. So that was, some major good stuff happening during these El Ninos. But note, we quickly went into La Nina and I got divorced. It's terrible. But the good news is that the very next El Nino, I got remarried. And my current wife is not as susceptible to these La Nina episodes, so we're still hanging together here. And then finally, in 2010, I got an appointment in the School of Natural Resources and the Environment on the tenure track. And if everybody sort of knocks on wood here on the tables, with any luck, I'll get tenure in about a month. So that's my life in 10 El Nino related episodes. So yeah, thank you for pointing out that I didn't explain what this graph is. So this is an index of El Nino based on a combination of sea surface temperature and atmospheric circulation variables. If we're in the red there, that's an El Nino episode. If we're in the blue, that's a La Nina. Remember, La Nina, drought here, El Nino, flood here. Okay, Act 2, under Arizona skies. So I want to talk a little bit about what's been going on in the climate of our region. Starting with this Pima County graph of maximum temperatures. So the red lines, the one that's waving up and down here, starting in 1895 and coming out to sometime this year, is the annual maximum temperature. And the blue dots are the 11-year averages of those temperatures. So the blue ones are giving us sort of the slower variation in temperature. And then there's a black line going across. I wish I could point to it. It's a little bit above the middle of the slide, and that's the average. Anyway, what we can see here is that there's a lot of variation from year to year in temperature. Some of that is due to our El Niño and La Niña episodes. There's also a pretty strong trend towards increasing maximum temperatures. And then you can also see, if you follow the blue dots, it's a little bit like a roller coaster. So there's some long-term variation also that again has to do with the behavior out there in the Pacific Ocean. And we see the same sort of thing with a little more pronounced trend with minimum temperatures. In contrast, if we look at precipitation, again, we see a lot of year-to-year variation, but we don't see any strong trend the way we do with the temperatures. Instead, we see some periods, like early in the 20th century, that were relatively wet in Pima County. The middle of the century, we see a dry period associated with the 50s drought. Then in the 80s and 90s, when I was either playing rock and roll music or moving here to Tucson, we had a series of El Niños here. It was pretty wet. So again, a wet period. And then most recently, we've been in one of these episodes of drier conditions. So when you put together the trend in temperature with precipitation that's not showing that trend, but it's showing a lot of variability, it has an effect on our region. And so I will, in the next several slides, talk about those effects, drawing upon this new book, The Assessment of Climate Change in the Southwest United States, that I had the good fortune to be the lead editor of. And if you do show up at the Tucson Festival of Books, you can purchase the book there. I don't earn a cent from it, but Island Press does pretty well, I imagine. Anyway, so this sort of thing that I pointed out for Pima County is actually happening throughout the greater Southwest. So what we see in these maps are individual long-term weather stations, and we're seeing the trends represented, the trends from 1901 to 2010, represented by the colors, and you can see the legend over on the right-hand side in both degrees Celsius and degrees Fahrenheit. You got minimum temperatures on the bottom and maximum temperatures on the top. And most of these are warm colors, which is a positive trend, increasing temperature. So basically what we see is a pretty geographically coherent signal of increasing temperature across the region. And with precipitation, very similar to the time series graph that I showed you, we see so I failed to mention, but if the symbol is colored in, it means that it's a statistically significant trend. And if it's just a little plus sign, it's not statistically significant. So with precipitation, we both see much fewer statistically significant trends, but we also see some in the southern part, for example, that are decreasing, and then we see some in the northern part that are increasing. So there's a lot of spatial variability there. So, those are watersheds, yeah, the squiggly black lines on the map. So anyway, that combination, again, of increasing temperatures across the region and precipitation that's not showing strong trends has a big effect on the snowpack of the region. And this is, of course, really important for water supply, because snowpack is the thing that feeds our water supply. So some of the things that we've been observing include earlier snow melt at elevations around 8,000 feet or lower in the Colorado River Basin. We've been seeing a greater fraction of late winter and early spring precipitation falling as rain rather than snow at some of those lower elevations, and earlier runoff into the streams. And that is one of the many factors that is exacerbating drought in our region. So this is my cue to talk a little bit about another book, and Yvonne, pay attention here, called Groundwater, that I had the good fortune to be associated with, and I wrote a very small essay in this. Ellen McMahon, who's sitting here, has put this project together with a couple of colleagues at the U of A, and it's really a lovely, lovely artist and scientist collaboration. A lot of real good work by students at the U of A. At any rate, I won't bore you by reading the essay, but my essay is kind of a lament about some of the choices that we've made, consciously or unconsciously, with regard to the way we manage water and the way it impacts us here in Tucson. Because in the book we studied the dry Rito riverbed. So one of the points that I make is that, again, that snowpack is so important. About, I want to say 15 or 20% of the surface of the Colorado River Basin, primarily in high mountains, is what contributes about 80% of the water that flows in the Colorado River. And it's so important for us here in Tucson. But, you know, from some of the choices that we've made about how we allocate water, the river very seldom makes it here to its mouth in the Gulf of California. So, you know, this I think is a underreported tragedy that because of our water management choices, which allows us to thrive here in Tucson, Las Vegas, Denver, Phoenix, Los Angeles, other desert cities, and we do a lot of agriculture and so on, but we've basically starved a really important and formerly thriving estuary at the mouth of the Colorado River. And, you know, it's a sin, really, to do that. At any rate, so that's all part of my essay in Groundwater and part of the lament. But the thing that I really want to celebrate about the book is that it was a fabulous collaboration, again, between people thinking about the science of this and artists thinking about how to look at this dry riverbed, how to communicate things about water and our environment in really creative ways. One of the graduate students who was involved in the project, Camden Hardy, walked the 23, 24, 25, 26, 22 miles of the Pantano Wash. And at every mile, he set up a pinhole camera and took photographs. And he also, he did a little video recording at each mile. And he also cataloged what he found in the riverbed. And you can see that on the glass in this display. Mile 4, 4 shopping carts, 3 water bottles, 2 beer cans, and so on and so forth. So it was a really you know, poignant and interesting way to look at things. He even cataloged this with the shoes that he wore to walk those 22 miles. Other students, this was Jess, and I forget her last name. Anyway, she did a project on the local extirpation of species along the Rito-riparian corridor. And that local tragedy, again, that has to do with the way we manage water and the way we, really didn't understand at the time that we were drawing down this huge groundwater resource that feeds the riparian zone along our rivers. Robert Long did some really wonderful illustrations at the Sweetwater Accidental Wetland. So he did kind of a really nice natural history. And one of the students, Matt, did some work on the kinds of architectural design that might help us live more sustainably in this region. So it's a really very rich collection. I urge you to have a look at the copy over there. It would be remiss of me to say that all of those trends that I pointed out in increasing temperature and the combination of that with variations in precipitation, the occasional drought episodes, also have dire consequences for our forests. And one thing that we've seen in the Southwest is a really extensive conifer forest mortality. On the order of 20 to 25% of our conifer forests have died in the last decade in the Southwest. And this is a continental phenomenon that occurs basically from northern Mexico all the way to Alaska. Again, the main driver here is increased temperature, putting stress on the trees and enhancing the life cycle of insect pests that attack the trees. And also there's a connection to wildland fire. With warmer temperatures, we have that shorter snow season. It dries out the fuels faster, and given the fact that we've made some management decisions that give us overstocked forests, we've had a threefold increase in the acres burned in our region just in the last 30 years. So that's stuff that we've seen under Arizona skies. And now we'll briefly look into the crystal ball of the future in Act 3, looking at some of the results of climate models. So models, I frequently mention, are these sort of necessary evils because we really don't want to do experiments with the Earth, even though ultimately we are doing experiments with the Earth. Anyway, the models give us a chance to do multiple experiments and see what we can learn. So climate models use mathematical equations to represent this very complex system with the ocean, the atmosphere, the snow-covered surfaces, the land surfaces, and all the interactions between them, plus all of the greenhouse gases that we put into the atmosphere. And we know that models are imperfect, but they are instructive. One of the biggest uncertainty as we go into the future is the amount of greenhouse gases in the atmosphere. And the reason I say that is that we don't, the greenhouse gases in the atmosphere are a function, or the increase in the greenhouse gases in the atmosphere that trap heat in the lower part of the atmosphere are a function of our economic activity, our laws and policies, and so on. And we know that we can't predict those economics and laws and policies and the way the politics between countries and so on, even a year in advance. So instead of trying to predict those things, we use multiple scenarios of possible greenhouse gas futures based on considerations about things like economics, technology development, and population growth and things like that. So based on an assumption of continued high greenhouse gas emission rate, which is what we've been doing for the last century or so, these are the kinds of increases that are projected for the Southwest region for 3 30-year periods, 2021 to 2050, and so on. There are temperature changes between those periods and the recent 1971 to 2000 average. And at top, we see the change in annual average temperature in degrees Fahrenheit. So by the middle of the century, across the region, if you averaged across the region, 5 degrees Fahrenheit increase in temperature. By the end of the century, 8 degrees Fahrenheit. And if you look at the colored dots, those are the different seasons. So the biggest increases are for the summer and fall seasons. And you can also get an appreciation for the range of changes that these models are projecting by looking at the plus signs. Those are the individual model projections for our region. The dots are the averages. So again, if we continue globally to emit lots of greenhouse gases, we'll see this increase in temperature. Now, it's really hard to get a handle on annual average temperature, at least it is for me. So Tucson's annual average temperature currently is 69 degrees Fahrenheit. Yuma is 7 degrees higher, and it's about 1,500 feet lower. So if we continue globally to emit greenhouse gases at this rate, by the middle to the end of the century, we can expect our temperatures to be more like those of Yuma, or like being at a place 1,500 feet lower. In addition to those average annual temperatures increasing, we also project increases in some of the extremes, extreme hot days, fewer cold nights, longer heat waves. And in some work that I've done with colleagues at the U of A, we project for Tucson, by the middle of the century, a month longer of days over 110 degrees. For precipitation, it's a very different story, just as it was in the observed record. So we don't really see a big trend in precipitation. Maybe if you look at the yellow dots, maybe some decline in the springtime and perhaps a little bit in the wintertime. And the way this plays out over the basin is very much like the trends we've been seeing. Some parts of the northern part of the basin may get wetter, and some parts of the southern part of the Southwest, including where we live, are projected to get maybe 10 or 15% drier. So again, the upshot of this is less snow, less soil moisture, less water in the reservoirs, more pictures like this one where our water supplies, our surface water supplies, are vulnerable. And in fact, this graph, which is in the book that I mentioned, The Assessment of Climate Change, is from work by the U.S. Bureau of Reclamation, not exactly a bunch of tree huggers. So the red line is the demand for water in the Colorado River Basin. The blue line is the supply. And what we can see here in the observed part of the record on the left side of the dotted line is that demand now exceeds supply in the Colorado River, right? Basically tells us if we continue like this, we're screwed. If we go to the right, those are the climate model projections, and they're kind of fuzzy to show the range of projections. So the projections are increased demand, but no projected increase in supply. In fact, probably a slight decrease in supply. So that's the kind of future that we've got coming our way if we do nothing to reduce the rate that we're emitting greenhouse gases. And those the projections are for mid-century, somewhere between 10 and 20% decrease in stream flow, shown here by these downward pointing triangles for different stream gauges and locations in the Southwest. Other implications of projected climate change are for an increase in acres burned across our region, threats to the amount of water available for agriculture, and also for some long-lived crops like tree crops that have a very long rotation and need cold temperatures in the winter in order to produce blossoms and fruit in the springtime. And implications for public health in terms of extreme heat and the effect on disease-carrying vectors like mosquitoes. So that's the grim projections for the future. Act 4, what in the world? As in, what in the world are we doing about this stuff in our region? So one thing that we're doing, and I think we're starting to do this pretty well, is actually plan for the future. There's a lot of awareness in the absence of a federal policy until last year. The leaders in planning for climate change have been non-governmental organizations, cities, to some degree Native American tribes, and to some degree states like California and Colorado. So there are a lot of climate change action plans out there. There are a lot of plans for adapting to some inevitable changes. So let me mention, go back here, about some of those plans. And in the description of this talk, I mentioned a word, apocalyptimist. So this is a moniker that Claire Zucker from the Pima Association of Governments gave me because I come on pretty heavy with the doom and gloom stuff. But the optimistic side has to do with this planning. So one of the case studies in the recent climate assessment is case studies of climate choices for a sustainable Southwest. So I'm going to read from that. Cities are emerging as the leaders in setting policies, preparing risk assessments, and setting targets for the reduction of greenhouse gas emissions. Organizations such as well, I forget what the acronym is, but it's an organization called ICLEI, something like the League for Environmental Initiatives, the Mayor's Council on Climate Change, and the C40 Cities Climate Leadership Group have provided successful venues for cities to raise awareness and disseminate best practices. Nationwide, most of the climate action at the city level is still focused on reducing greenhouse gas emissions. And recent assessments of these efforts have been critical of the likelihood of reaching some of these stated goals. In the Southwest, more than 140 cities are members of this initiative of the League of Environmental Initiatives, ICLEI. Success stories include Fort Collins, Colorado, which has not increased its annual greenhouse gas emissions since 2005, despite 5% population growth. Fort Collins is hoping to reduce greenhouse gas emissions by 80% below 2005 levels by the middle of the century. Utah, an interesting place, has similar kinds of political challenges as Arizona, reduced its greenhouse gas emissions by 31% between 2005 and 2009. And cities such as Los Angeles, Boulder City, Nevada, Pleasanton, California, are also promoting initiatives to expand locally based renewable energy initiatives. So now, I'm proud to say that Tucson's also one of these cities, even though not mentioned in the case study. The red line here is Tucson's, or Pima County's, greenhouse gas emissions. And down there, the blue line is our goal. It's a modest goal to reduce greenhouse gas emissions by 7% below 1995 levels, 1990 levels, thank you. And this was adopted by the mayor and city council in December of 2011. So we are actively engaged in a process of trying to reduce this through various kinds of initiatives for vehicle fleet, electric cars, expanding our bike paths and making more opportunities for transit by bicycle and other means, putting in the streetcar line, and so on. So Tucson's one of those proud cities. Let me read to you from another case study from maybe another unlikely source. This is the Levi Strauss Company. So Levi Strauss & Company is a retail company, as you know, based in California, that has started to take steps to reduce its contribution to climate change. It groups its climate-related goals under 3 categories: reducing climate change impacts resulting from production, reducing impacts from its facilities, and promoting environmentally friendly use and disposal of its products. Since 2007, Levi Strauss & Company has reduced greenhouse gas emissions by 5.84%. This reduction came despite a 6% increase in its real estate portfolio. The company launched a Levi's waterless jeans product line that reduces both water and energy consumption. The company was also active in supporting the California Global Warming Solutions Act, AB 32, and joined the campaign against Prop 23, which aimed to overturn that very enlightened state legislature. So Levi Strauss supports a nonprofit program focused on teaching irrigation and rainwater capture techniques in India, Pakistan, Brazil, and Central Africa. Currently, 5% of the cotton in its jeans production is grown using sustainable methods, and the company aims to increase that to 20% by 2015. So it's encouraging to me to hear about these kinds of actions, even in the private sector. There are also water management initiatives, some of which are already being done, and we expect that these kinds of things will be implemented even more in the future. The city of Las Vegas pays people to rip out their lawns and put in xeriscaping. Pretty good. Tucson is really well known for rainwater harvesting, and this is catching on in many arid cities as a way to conserve water. These fanciful photographs from the Salt River Project website illustrate some of the locations where we use these massive settling ponds to bank Colorado River water as a hedge against future drought. California has actually built new reservoirs so that if we ever get another one of those gigantic 1982 or 83 El Niños, any of the excess flow can be captured and put to so-called productive use. And the city of San Diego is building an ocean water desalination plant to augment its water supply so that they have enough potable water for future growth. So there are all sorts of solutions, from conservation, which I think we all would probably agree is a good thing to do, to these kinds of high-tech solutions. So there's a lot of stuff going on to make you flex your optimist muscles, even if you're an apocalyptimist. Other things that are being done, every one of the federal agencies now has to have a climate change plan, including a plan to adapt to possible future change. A lot of these plans are doing things like having facilities that put in solar or wind energy. They're doing restoration of our treasured riparian zones, or using prescribed fire or thinning to maintain forest health. And this funny diagram at the lower right illustrates a planning strategy that a lot of agencies are using now, which is called scenario planning. And the idea is to use multiple, as a hedge against a very uncertain future, especially with regard to precipitation, to look at multiple possible futures and try to come up with plans that are robust regardless of whatever the future is. Act 5, final act. The real reasons that you should be concerned about climate change. Well, for one, it affects wine. It affects the wine-growing regions of the earth. So I'm going to quote from an article from Australia. So this one says, this is from climate change scientist and wine expert. That's a title I'd like. Leanne Webb. So she explained that ripening times were changing and grapes are maturing more quickly with the warming temperatures that have been affecting Australia. All my modeling is showing that if climate warms up, given that a variety is able to ripen well in a region in a present climate, the actual quality that we will see will be decreasing. And that's because these wines are becoming sugar heavy and more highly alcoholic in their content. For some of you, you might like those bold wines, but, and I quote, this is from one of the vintners there, in a warmer climate, the heat and earlier ripening period creates richer and fuller bodied wines. But we are seeing a consumer demand for finer wines, more elegant wines, and that does not augur well for people who are already making those richer, fuller bodied wines. We've seen vintages ripening by a day to a day and a half earlier per year for each of the last 15 years. So we know this is happening. This is from the wine folks. And they are working on controlled warming experiments, growing vines in controlled warming areas so that they can determine methods to adjust their winemaking. This is from another article on wine growing that came out in the Proceedings of the National Academy of Science last year. And I've got a couple of maps that show in red areas that will no longer be able to grow grapes, and in blue, areas that will become, have openings for growing some of these wine grapes. So we can look forward to northeastern Washington, western Idaho, as the future wine belt for the U.S. One of the authors says, it'll be harder and harder to grow those varieties that are currently growing in places. This is the map for Australia. So they don't have much margin in Australia. They can go to Tasmania, the island over there in the lower right-hand corner. But this is the map for Europe. So the author says it'll be harder and harder to grow those varieties that are currently growing in places in Europe. It doesn't necessarily mean that they can't be grown there, but it will require irrigation. They don't currently irrigate, and special inputs, and I think he's talking about fertilizer and maybe genetic modification to make, and that these kinds of inputs will make it more expensive to grow wine. And again, going back to the US, some newly identified wine-growing regions of the future are wilderness areas such as those around Yellowstone Park, where there are already clashes between ranchers and wolves. So, anyway, so that's another, I think, very important reason to be concerned about climate change. But another one is it also affects beer. So higher temperatures, longer droughts punctuated with intense rainfall, more resilient pests and plant diseases, all of which are associated with climate change. Whoops, wrong article. Must be this one. Okay, here we go. Climate change could start drastically affecting global barley production, which obviously drastically affects the beer industry. And there are geneticists who are working to discover what parts of the barley DNA help it thrive in more drought-like conditions. So GMO beer, that's what we've got to look forward to here. Also, plant scientists from Europe are tending to breed new varieties that can withstand warmer climates for hops, which, if you like IPA, that's GMO hops. Okay. And as if that weren't bad enough, we move into other food groups like cocoa and chocolate. So this article says more than half of the world's chocolate is sourced from Ghana and Ivory Coast, where cocoa growing topography will be very different by 2050, according to a study by the International Center for Tropical Agriculture. Climate change brings not only bad news, but it does bring opportunities for those who know how to adapt. Farmers, though, could begin to see declines in cocoa production by 2030, says the report. And then, you know, the final nail in the coffin is coffee. So here's the one where higher temperatures, long droughts punctuated by intense rainfall, and more resilient pests and plant diseases, all of which are associated with climate change, have reduced coffee supplies dramatically in recent years. Additionally, warming has expanded the habitat and thus the range and damage of the coffee berry borer, a grazing predator of coffee plants. This pest is placing additional stress on all coffee crops, as is coffee rust, a devastating fungus that previously did not survive cool mountain weather. Costa Rica, India, and Ethiopia, 3 of the top 15 coffee-producing nations in the world, have all seen dramatic declines. So, plenty of reason to think that this is an important problem. So let me just conclude with a more personal note. That's me without a beard in the middle. The gentleman to the left of me in this photograph is our Western regional climatologist. His name is Kelly Redmond, and he's a dear friend and probably, like Walter Cronkite, the most trusted voice in climatology in the Western United States. And he was recently diagnosed with liver cancer and blood clots in his lungs. He's about to start chemotherapy, and this has a lot of climatologists throughout the United States just all shook up. So I'd like to finish by reading a poem that I think reflects back on that excerpt from Marge Piercy about blessing and living fully and really being aware and paying attention to everything in our life and not taking anything for granted. This is called The Last Time, and it's from the poet Marie Howe. The last time we had dinner together in a restaurant with white tablecloths, he leaned forward and took my 2 hands in his hands and said, "I'm going to die soon. I want you to know that." And I said, "I think I do know." And he said, "What surprises me is that you don't." And I said, "I do." And he said, "What?" And I said, "Know that you're going to die." And he said, "No, I mean, know that you are." So I encourage us all to take this stuff seriously, take it to heart. Also, to live heartily, hug each other, kiss each other, say we love each other, and that's what climate's got to do with it. Questions? Decline in demand for it's a yeah. I'm not sure why there's that decrease. I mean that was no. I don't think so. Yeah. No. If right. If anything, I think it might be related to less supply, and that we're in reaction, perhaps delivering less water. But I'm not certain about that. John's nodding his head. Oh yeah, okay. I'll repeat the question. Yeah, sure. Okay. Yeah. Other questions? Yes, sir.
The question that many people always how do you know the model is accurate? So let me just ask you a question. Tell me about the model that was used, specific parameters that were good, and how it was validated through
So the question, thank you for that question. The question is about climate models. One of the issues that people who don't believe that there's human-caused climate change raise has to do with our reliance on these models and their ability to project future climate. And the gentleman wanted to know what kind of parameters are used in the model and how the models are validated. So all of those graphics that I showed you used multiple global climate models. There are probably on the order of 25 to 30 modeling groups in the world. So there's kind of a maximum of that number of models. For this study for the Southwest, we used 16 of those that were available at the time that we were compiling the report. And the models are not, they don't use statistical relationships. These models use basic physics. So they're using things like the conservation of mass, conservation of momentum, conservation of energy. And so they're basically using differential calculus to express the various complexity in the transfer of energy, moisture, and other things throughout that complicated climate system, including the ocean to great depth, the atmosphere to great height, and the interactions with the land surface and so on. They are validated by their ability to in a couple of ways. So one of them is by their ability to get certain aspects of the climate system right. So some of the most fundamental ones are, do they get the change in the course of the day correctly? You know, does it warm up during the height of of sunlight, and does it get cold at night in a reliable way? Do they get the seasonal cycle correct? Are they getting the months when the temperatures are increasing and then when they decline? Is the precipitation coming at the right time of year? Are they getting the wind belts right? Are they getting the westerly winds in the mid-latitudes, the easterly winds in the tropical latitudes? Are we able to see some phenomena like the El Niños and the La Niña in the model oceans? So those are some of the ways that the models are validated. For some of the regional studies that people do, these models have very coarse output, on the order of about 200 miles on the side of a grid cell, if you imagine the globe being sectioned into a continuous spherical grid. So we do a process called downscaling, which does use statistical relationships to get down to finer spatial scales so that we could look at some of the local variation in a little better sort of way. And some of the experiments that we've done, for example, looking at future climate change in Tucson, is we've selected a subset of models that have a good El Nino and La Nina response, because we know that those are very important for the winter climate here, and also that have a good monsoon, North American monsoon response here. And we've tried to use those preferentially for Tucson because we think that'll give us the best idea about, again, possible futures. And we call them projections rather than predictions because there's this enormous uncertainty with the greenhouse gas emissions. Other questions? Howard, sir, yes.
One thing I haven't been able to get straight in my head, you showed your slide of the increasing the maximum temperatures increasing. But in fact, what we're hearing a lot of is 10-year running average is not good at
In the Southwest or globally? Globally. Okay. Yes.
So, how does that guy back to every year seems to be like one of the top 5 warmest years?
Yeah, sure. Great question. So this question is about global temperatures, and the observation here is that temperatures have been globally increasing and increasing and increasing, and then in the last decade or so have kind of leveled off. So one aspect of that is that there's variability in the system. And so we're seeing some of that variability. In fact, if you broke down the global temperature graph, you would see that there have been many of these periods of increase, decrease, increase, level off, decrease, and so on. Variability is not going to go away. And part of that variability, one of the theories for this is that the oceans have been taking up more of the heat. So globally, the atmospheric temperature has leveled off somewhat, but the ocean temperature has increased. There was a study that came out late last year that looked at Arctic temperatures and took a, I don't recall the details of this, but the upshot is that the records that we've been using to measure Arctic temperatures have been underestimating the increase. So that might contribute to more increased global temperatures, since the Arctic is one of the regions that's increasing most rapidly. So those are two of the explanations, or three. There's the variability, there's the ocean heat content increase, which is well documented, and there's this apparent bias in the Arctic temperature measurements. So should we arm wrestle or no? No, I take this as I take this as a friendly question, and an important one.
Just this morning in a paper, NASA issued a statement that, well, maybe CO2 didn't have a big effect. Do you care to comment on that?
No. So the gentleman mentioned that in the paper this morning there was an article or a press release from NASA saying that perhaps CO2 doesn't have as great an impact as we thought. And I haven't had a chance to look at that. I don't know the science that's based on, so yeah. So, other questions? Comments?
What are we going to do with no coffee or wine?
No, I'm going to guess that we're still going to have coffee and wine, but it's going to cost us a lot more. So, well, I don't want to make assumptions here, but I'll guess that you're retired. So you might be buffered a little bit from this. But maybe for people my age or the age of those handsome young people in the back, they might want to sock away a little extra in their 401 retirement accounts. Oh yeah, so yeah, that's good. Maybe the Southwest here will be a chocolate-producing region. Okay. Anyway, thank you very much for your attention, and it's been a pleasure.